Hey, Grant here. I've been studying the GEET conversion for combustion engines for a few years now, and what I really love about this technology is that it's fringe tech at garage tolerances. Literally, anybody can build one of these. You're building a plasma reactor with items that you can get at your local hardware store, and you can convert any combustion engine to do it. Here's one that's mounted on a push mower. You can see the plasma reactor right there. It's another thing I really love about these is that it's really like a real-life Mr. Fusion. Even though the system does require a minuscule amount of fossil fuel to start up, once the reactor gets dialed in, it'll run on just about any water. It'll crack anything into its constituent atoms. Water, Diet Pepsi, urine, orange juice. Heck, you could hock a loogie in that thing and it's going to crack it into its constituent atoms and run your motor on it. So anyway, I decided to try to find a video on YouTube that I could share that explained the science behind the GEET conversion in a quick and concise manner, and I couldn't find a single one. There's a lot of great videos that show design, but nothing that really got down to the nitty-gritty of the science in a quick and concise manner, and that's what really gets me to my main point here, and that is no fringe technology is ever going to take off if you don't explain it quickly and concisely in a way that the layman can understand. So I figured, hey, I'll put together a quick video explaining the science behind the GEET. I'm not going to get too detailed into the ionization stuff because that really does get complicated, but I am going to include that in what's going on here. GEET stands for Global Environmental Energy Technology. More specifically, this is a plasma reactor in the form of two iron or steel pipes that you're going to add to your system and a fuel rod inside the inner pipe that you're going to add to the system. The sizes vary. Actually, the diameter of these pipes and the diameter of the fuel rod is going to depend on the size of the engine, and the length of the pipes and the length of the fuel rod are going to depend on the type of fuel that you're running in your system. Obviously, if you're running propane, there's a very small molecule. It's easy to crack that molecule into its constituent atoms. You'd be using a fuel rod of 1.5 to 2 inches. You don't need very much space for that reaction to happen. If you're running gasoline, this rod is going to be between 5 to 7 inches long. That's a larger molecule. It takes a little bit more work, a little bit more time for the reaction to happen. If you're running diesel or used motor oil, let's say, it's going to take a much longer rod, well over 7 inches. Why? You're talking about a huge molecule. It takes much longer for the reaction to happen. You need a bigger reaction chamber, a longer fuel rod. That gets me to another thing that I really like about the GEET technology is it combines several feats of very simple high school physics, but when combined in this manner, literally turn your vaporized fuel into a plasma state, which is going to increase the efficiency of the engine many fold. Most GEET conversions appear to require 10 to 20% of your original fossil fuel, be it gas or diesel or propane or whatever, and then a 80 to 90% mix of other liquid, be it water, urine, Diet Pepsi, orange juice, whatever. So basically, imagine how much you get out of $50 of gas in your car. Imagine going that same distance with just $5 in gas. Now, as I said, to apply the GEET conversion to an automobile, it does take a bit more modification than what I'm going over here, but it is possible to do. So what are these simple feats of high school physics that come together in order to turn your fuel into a plasma? Basically, we have colliding temperatures, we have a resulting magnetic field from those colliding temperatures, we have ionization of our fuel vapors, and we have the fact that we're sending our fuel through the system at Mach 1, which the speed of sound serves as a further destabilizing factor, helping us crack those molecules into their constituent atoms. As in water, H2O becoming H plus H plus O. The two hydrogen atoms and oxygen atom that were previously connected together are now disconnected, free-floating atoms ready to be used as fuel. You may be thinking, okay, well, to turn water into plasma, we need a temperature of 3,800 degrees Fahrenheit. Well, that is true, but it's not true in a vacuum. In a vacuum, those temperature requirements are reduced to about 720 degrees, and considering that our exhaust comes out of the engine at around 1,000 degrees Fahrenheit, you are well within the parameters to create that kind of an environment. Let's actually take a look at what's going on. Regardless of the engine that you're going to use, you're going to remove the carburetor and you're going to replace your fuel tank with something that looks like this. This is just a model of a bubbler, basically steel wool inside a glass jar. Put your 10% gas, 90% water mix in there. The vacuum from the engine is going to suck your fuel up through the steel wool in those nooks and crannies. It gets vaporized. That vapor then sent down into the system. Now, when your vaporized fuel gets down here, it's about 110 degrees. Your engine exhaust is being sent into the system as well. It's about 1,000 degrees here. Now the exhaust is in the outer pipe, the fuel is in the inner pipe. These two substances never physically interact with each other, however their temperatures do, and that results in a very powerful magnetic field. Once the system is dialed in, your fuel rod is going to actually float in that magnetic field, not even coming in contact with the inside walls of the inner pipe. That fuel rod, 1, is displacing your fuel vapors, and 2, it's acting as a Venturi vacuum. So the displacement pushes the ionized fuel vapors up into the wall or ceiling of the inner pipe, thus heating it because the exhaust is heating that pipe from the outside. Also though, when your ionized vapor hits the remnant magnetic field of your steel components here, it gets deflected, causing it to vortex around the fuel rod and move very quickly. Again, you're getting up to the speed of Mach 1 like that. The actual cracking of the molecule into its constituent atoms happens at near the center of the plasma reactor in what's called the plasma pinch. And the reason that it's called a plasma pinch is because your ionized vapors are not only being magnetically squeezed, okay, but they're being superheated at the same time. The molecules, your fuel vapor molecules, are going to be cracked into the constituent atoms. Basically, they're elemental gases, and those elemental gases then continue through the fuel line and back into the engine. The wonderful thing about this system is it recycles your exhaust, which as far as I'm concerned we should have been doing since the 50s. It's absolutely ridiculous to me that we put these toxic materials out of our tailpipes. I remember being a very young kid and thinking, or middle school, high school, when I first learned about what our exhaust was putting into the atmosphere, and wondering to myself, why aren't we recycling that exhaust back into the system and reusing basically the fuels that we still have after combustion. So anyway, here's our exhaust coming through the outer pipe, then coming up, and it's blue here because it's cooled. I made this one represent more the temperature. Hot exhaust comes out, runs through the outer pipe, gets cooled, runs back into the bubbler. So any of your remnant and still usable large molecules get rebubbled, vaporized, and sent back into the system. That results in the fact that any exhaust that you would have is darn close to clean air. Now just real quick, I want to talk about thermal inertia. This, in my opinion, is the reason why the plasma pinch technically doesn't happen right at the center of the reaction chamber, but rather happens closer to the cooler side. There's something going on here called thermal inertia, and I think that's what accounts for this. Basically, your exhaust is coming out at approximately 1,000 degrees. As it travels through, it's being cooled by the fuel vapor. So say it gets down to about 700 degrees, right? Then it would drop down to about 450 degrees, and then there's a spike further down. Basically what's happening is the fuel temperature is so exceeding the temperature of the exhaust that it reheats the exhaust. The exhaust goes from about a 450 degree temperature back up, spikes back up to a 700 degree temperature, and I think that's what accounts for the plasma pinch actually happening a little further down the line rather than happening right in the center of the reaction chamber. What's really shocking to me is the fact that there's still so much controversy over the GEET motor. And perhaps that's the result of not enough videos or not enough time being spent explaining the science behind it. The bottom line is we have a plasma reactor at Garage Tolerances. We have something that anyone can build from items that they got at the hardware store to convert the hunk of metal that they already own into an extremely fuel efficient green machine. There's no reason, considering these things, there's no reason why we need to stay slaves to the big oil industry. We can change that, and we can change that by sharing these types of technologies. So please keep spreading the word. Please keep exploring Fringe Tech, and I'll see you next time.